Hello everyone, my name is Omero and I'm gonna solve this question of signals and systems. First, I have my transfer function h of omega equals 2 over 2 plus j to omega times a to the j omega. I need to find and sketch the system's impulse response h of t. Well, I know that my h of t is the inverse Fourier transform of h of omega. And over here I have that my h of omega can be written like that. And I have this part of h of omega that is my my time shift property. I can use my time shift property. And this part of my function h of omega has a straight inverse Fourier transform in my Fourier transform table. So h of t can be written off as my function h of minus t u of t shifted in the time frequency in the time domain by 1 to the right, to the left. So h of t is equals to h of minus t plus 1 times u of t plus 1. And here's a sketch of my function h of t, my impulse response. It asks here if my system is practically realizable. Well, it's not, because my system is not causal, so I cannot do this in the real world. Let g of t equals cosine of t be the input of the system. My g of omega, I have a straight pair on the Fourier transform table, and I can write j of omega as my Fourier transform of g of t equals pi times delta of omega minus 1 plus delta of omega plus 1. That is my omega naught of g of t. And also asks what is my output y of t, since my output is the convolution of h of t with g of t. Well, I could convolve these in the time domain, or I could multiply in the frequency domain, but I can also, since I know that my output is the magnitude response of my input and my system response function, and I can just multiply my j of the magnitude of j of omega with h of omega, and I can sum my my phase of the two functions and just have my y of t equals the square root of 2 over 2 times cosine of t plus 1 minus pi over 4.